Hello! It's the Queen of Mathematics back with you again today to teach you to solve absolute value equations and inequalities. Aren't you so excited? Without further ado, we will continue our online lessons today. Ooh, did I just go Australian? Maybe. Anyway, just thought I'd make it a little fun. Let's do this. I encourage you to write down the examples as we go today. This was a struggle a little bit when we were doing it in class, but hopefully getting this a second time around, we can really focus in on the most important things. We won't have to graph these while we're online here when we did it the first time we did, and you may be asked to later on. We're going to focus on how to solve them, okay? So example 1, the absolute value of x equals 7. So remember, absolute value means distance from 0. So what we need is this value has to be 7 units from 0. And so the answer to this, we know that 7 is 7 units from 0. We also know that -7 is also 7 units from 0. So it's in the negative direction, but we're talking about on the number line, okay? And so the equations, which are 1, 2, and 3, are all kind of using that idea, okay? So basically what's going to happen when we're solving the absolute value equations is we're solving really the positive version and the negative version. So like here, this is saying 5x equal 30, and we're also solving 5x equal -30 to get two separate answers here, okay? And most of you can do this in your head, but you get x equal 6, and we get a second answer of x equal -6. And the wording doesn't matter on the equations. You can say and, you can say or for either of those. So I want to point that out because it is going to make a difference down here on the inequalities. So this is our first answer. Here's our second. And we'll continue with one last equation here. And again, we're going to solve both of them. So 2x plus 1 equal 11. That's kind of what it says without our absolute value. But we're really also saying that 2x plus 1 equal a -11 is also going to give us another answer to this question. So you can either solve these as a shooter problem or you can solve them using a chart. I'll do both. Let's start this one with like a shooter. So 11 would already be safe. And the first one that would get out would be this 1. So we would subtract 1 on both sides. And so we get 2x equal 10. And then we would divide by 2 to get an answer of x equal 5. That's one of our answers. You can also do this if you're more comfortable using a chart. So I'll do that over here. And so x is on the left, numbers on the right. So 2x would come down, 1 becomes -1, -11 stays. And we would add those up. Oops, add, not multiply, add. So we get 2x equal -12. And we would divide to get rid of that 2. And our second answer would be x equal -6. And so that's how you solve absolute value equations. You're really looking for two answers. Notice that the top two were the same number, only opposites. But that's not always the case, especially when you get more things in there besides just multiplication when you're adding extra things to it. So don't just say, oh, I know it's 7, so it's got to be -7 as well. Okay, now those were pretty good when we went through in class. Where we started to waver a little bit, I'll say, is when we threw the inequalities and the absolute value in, because then the wordings of ands and ors became a thing. So example 4 is the simplest type of inequality. And that is when you just are saying the absolute value of x is less than or equal to 10. Okay, so again, just like the equation, we're going to split it up. My advice to you, and I don't think I did this in the beginning, but is to do, when you're doing the inequalities, do the negative to your left and the positive version to your right. So what you're really saying is x is less, or I'm sorry, we have to flip the inequality when we go negative. So we're saying x is greater than or equal to negative 10. And we're saying x is less than or equal to 10. We have to flip it when we're doing the negative version. Now, if you think about this and graphing it, right, this is how we decide if it's an and or an or. So x is greater than or equal to negative 10. So that would be like negative 9, negative 8, negative 7, negative 6, and all the positive numbers. X is less than or equal to positive 10. So that would be 9, 8, 7, 6, 5, 4. So if you think about the graph is going to end up meeting in the middle. It also, if we do it where the negative's on the left, we can cheat a little bit. Our arrows both point inward, meaning that this is going to be an and. We're going to say x is greater than or equal to negative 10 and x is less than or equal to 10. And this is our answer. You can also put those together if you wanted to do that. You could do negative 10 and 10 as your lower limit, upper limit, putting x in the middle, and then you just pay attention. So for the positive version, right, x was already there, so it's going to go this way. And the negative version, the alligator is eating the x, so we have to make sure that it eats the x here. So when we do it this way and we write and, they're pointing inward, but when we put that back together, they should be pointing in the same direction. Okay, last but not least, let's see if we can get through this one. Same advice. Let's start with solving the negative and flipping the inequality on the left-hand side. Okay, so we're going to say really 8x minus 4, and we're going to flip the inequality so that it goes this way, is less than or equal to negative 12. And the other one we're going to solve over here is 8x minus 4 is greater than or equal to positive 12. And then we're going to solve each of them either using the shooter problem or the chart. So again, I'm going to use shooter over here. Negative 12 is safe. So I start by adding 4 to each side. So then I get 8x is less than or equal to negative 8. And then I'm going to divide this 8 out. So I get x is less than or equal to negative 1. Notice I didn't reflip the inequality because I divided by a positive 8. So that's one of our limits. That's our lower limit. Over here, I'll use the chart. So if I charted it out, which you could do over here, we get 8x stays, 4 becomes positive, 12 stays positive. We add them up, we get 8x is greater than or equal to 16. We still have to divide by 8. And so we get x is greater than or equal to 2. And the nice thing about this is, since they're in order now, we can take a look at this. So notice that in this case, my arrows, this arrow is pointing left, and this arrow is pointing right. So automatically, since we did it in this way, we know this is going to be an or. It's the final answer is x is less than or equal to negative 1, or x is greater than or equal to 2. If you were to graph them, they would be going in opposite directions. And you can't put the ors back together like this, okay? So don't do that. Okay, so hopefully this second time around is a little bit, you got a little bit more out of this. Maybe you needed that to focus. Maybe you needed the queen to teach you how to do it again. Either way, If you have any questions, please email me. I miss you all so much, and I would love to hear from you, even if you don't want to email me a math question. I'd love to hear from you either way. Okay, hopefully you guys can answer the couple of questions that I put on the slideshow and be good to go. Have a great day, all.